Okay. We're starting, ladies and gentlemen. So we'll start off by talking about numbers and names that we have for numbers. So we categorize numbers in certain ways. Most of you guys have probably heard of things like real numbers, whole numbers, natural numbers, that kind of stuff. We're going to start off by talking about integers, which is definitely a bigger set of numbers. So integers, I wanted that to be red. Integers represents any number that is a natural number, any number that's a whole number, and then a little bit extra. So we'll start off by talking about natural numbers. Natural numbers is the letter N. And natural numbers come from the name a long time ago when they first started doing math. When they first started doing math, all they could really do was count, like basic things, right? Like 1, 2, 3, 4, 5, like that. Basic counting. They called them the natural numbers, right? So for instance, they always started at 1, and then they just went up as high as they could. We call those N, the natural numbers. Awesome. The number 0 is not a natural number. We haven't talked about it, but the number 0 refers to another group of numbers, and it's called the whole numbers. So a long time ago when they created this number system, they had their counting numbers, 1, 2, 3, 4, 5, 6, 7, 8, up to whatever, and then they realized, oh, hey, there's the number 0. We have to represent nothing, and that's how they created the number 0. That's the second group of numbers that was made. The third group of numbers that was made had to do with negatives. And they're like, okay, what do we do if we have negative something, right? You got -1, -2, -3, so on and so forth. That's the opposite of your natural numbers. It's all the negative natural numbers, which is the second part here. The opposite of counting numbers would be like -1, -2, -3, so on and so forth. So we've got the natural numbers, which is 1, 2, 3, 4, 5, 6, all the way up to whatever. We have the opposite of the natural numbers. That's -1, -2, -3. And then we have the number 0, which we're missing. 0 refers to the whole number, right? It's part of that group. Integers includes all these things. So it includes all your natural numbers, 1, 2, 3, 4, 5, 6. It includes the opposite of all of them, the negative version, -1, -2, -3, -4, -5, -6. And it includes the number 0. Awesome. We call that the group I. So I is for integer numbers. It starts at -infinity. Then we go -3, -2, -1, 0, 1, 2, 3. And it goes off into positive infinity. You've seen this represented on a number line, right? Like that shouldn't be anything too crazy new. Number lines, this idea of positive numbers, negative numbers, the number 0, all that jazz. Wicked. For layman terms, I'm going to refer to positive and negative versions as opposites. So whenever we talk about a number that's negative and a number that's positive, I'm going to call those opposite numbers. So for instance, the number 1 and -1 are opposites. The number -12 and +12 are opposites. Right? The opposite of each other. One's negative, one's positive. The other way we refer to them is as being the negative version of 1. So I'm just going to say the negative. Another term you might hear me refer to is the opposite symbol. Instead of saying opposite, I might say opposite symbol. Because all that you're really changing is the symbol in front. It turns from positive to negative, negative to positive. The number itself stays the same. Those are all terms that you might hear me say. Right? Opposite symbol, opposite, negative. All mean the same thing. Cool. The last thing, the last term that you might hear is the additive inverse. I never use that phrase. Okay, it is technically like the correct way to say things. I never use it though. So if you ever hear somebody say the additive inverse, that means the opposite sign. And that's what I would use. The opposite number, the opposite sign. I think it's way easier to understand than additive inverse. That sounds crazy. Means the same thing though. So if you're looking at the number 12, the additive inverse of that would be positive 12. Opposite symbol. The additive inverse of 50 would be negative 50. The additive inverse of negative 1001 would be positive 1001. The additive inverse of 5,634 is negative 5,634. Cool. You should have learned all those kind of ideas in the last couple of years of math. They probably put them on number lines. Right? So on number lines, this thing right here, where they have the number 0 typically in the middle, and then they go up as far as they want, down as far as they want, one way or the other. And then you could estimate in between those values, right? You could do decimals. We did number lines earlier with roots, right? We did root signs before. So these are things that hopefully you've seen or remember, so it shouldn't be that crazy to you. We are going to use number lines again because they help us with adding and subtracting, which we're going to do, and multiplying and dividing, which we're also going to do. And we're going to do it with fractions and all kinds of stuff. So number lines can be useful. That's why we're reviewing, just to see like what it looks like. Cool. Integers. We use integers all the time, right? So we'll come up with some random examples. I'll do the first one. So integers are used in everyday life. I'm going to talk about the temperature outside. Yeah. So for instance, we would refer to the temperature outside as being like negative 10.
It's not cold out.
Okay, so if it's not cold out, we would refer to it as positive 10. Right? We also have temperatures of, like 0, 3, negative 40. These are all examples of how we use integers. All it is positive, negative numbers. Where's another place that you might see positive or negative numbers? Yeah, Kenzie.
If you work in a bank, you take money out of an account, you put money in.
Awesome. Money. Money is definitely used as an integer. Typically, we talk about positive money, right? So positive money would be like the amount of money I have. Maybe you have like $10, right? Or maybe you have $2, a toonie. But you can also have negative money, which sometimes people have a hard time understanding. The best way you probably see it is if you ever look at your like online banking or something like that, if you have that, or if you see a receipt, they will usually have like money you've taken out of account, right? They use negative $20 and they'll put a negative. That represents $20 came out or came away from something. You could also have negative $5, right? Usually means you owe money or there's money taken out of something. Yeah, Drew.
And scores.
Scores. I agree. So scores in a game. Depending on the game depends on what you might see. We're going to talk about the game of golf because that definitely uses it. So when you go and you play a game of golf, say you have 4 shots to get in the hole. If it takes you 5 shots, they would tell you that the score on that hole is a 1 because it took 1 too many shots. If you went up to a hole that was supposed to be 4 shots and you did 3 shots, they would say it's negative 1 because you did 1 less than was expected. So you definitely do see these in scores. And you can do other sports, right? Like if you do basketball, football, anything like that, you can get positive, negative scores just depending on what you're doing. In darts, you usually have like a big number and you're trying to get down to 0. So you're getting negative numbers as you're going down. Yeah, for sure. If I play golf, you'll see a lot of like 10s on my scorecard because I'm not very good. If my friends play golf, maybe you'll see some -3s on there because they're way better than I am. They don't typically put 0s, but you could technically put a 0 in golf just for the record. They usually say even, but whatever. We'll call it 0. Same idea. The concept is integers are used all over the place. It's just positive, negative numbers. That's all integers really are. Cool. We're going to order some integers with the number line above. So if we look at example 2, we're going to put the numbers in descending order. descending. That means you want to go down. So you want to be your highest to lowest. You're going down. Our highest numbers are up here on the right side of a number line. Your lowest numbers are over here on the left side of the number line. So if we took these numbers and we wanted to put them in descending order, that means highest to lowest. You want to go down. The highest number that I have here would be positive 11. Right? That would be the furthest to the right on my number line. So I would start with 11. I would then cross it off. Then I would do the next highest number. The next highest number on that list is 4. So I put 4. The next highest would be 0. So I put 0. The next highest would be -3. Then -8, -9, -12. And I'm crossing them off as I'm placing them so I don't miss one at the end. I make sure they're all crossed off. That's kind of the idea between crossing them off. If I look, these numbers go from highest to lowest. If you think about it in terms of money, right? So maybe money in your bank account, descending order. The most amount of money is 11. That makes sense. Then it goes down to $4 in my bank. That makes sense. Down to 0 makes sense. Down to -3 means I have negative money, less money. Then down to -8, that means I have even less money. Down to -9, even less money. Down to -12, even less money. Right? That's called descending order. Descending, go down. Ascending order. Ascending order is the opposite, which means you want to go up. So you want to start at your lowest number and go up. I don't have a good way of remembering that ascending means up. I am good at remembering that descending goes down because the D and the D go together. Like descending, down. So ascending is the opposite of that. So if it doesn't have the D in front, then I know I'm going up. That's kind of how I figured out. Yeah, A is adding. You're going up. I like that. It's a good idea. So you would now this time start with your lowest number. Your lowest number would be the furthest left on the number line, which would be -15. The next lowest number would be -4, -1, 3, 4, 5, 7. Fantastic. We ascend and descend numbers all the time. So as you get older and you start creating spreadsheets for work or something like that, people always want to know what's the ascending order. It's a good way to rank things. What's the descending order? It's a good way to rank things, compare things. So it is definitely like a real life applicable thing that you would need to order numbers from lowest to highest. I think that's probably a skill you guys all already have. Right? Review. It's mainly review today. The next thing we're going to talk about is these two symbols. This guy and this guy. I'm going to do one in red and one in blue. Now, typically, people know what each symbol means, but they forget the words behind it. And as you go forward in math, you're going to use the words more often than anything. So you're going to have to know what it actually is saying. Definitely. The first guy. This one. That one means less than. So the first thing is less than the second thing. The other symbol is greater than. Yeah, and when we use it to place numbers, we use it. We use like the idea of a crocodile, right? You guys have probably seen that. So if you imagine that each one of those symbols is a crocodile biting something. So if we zoomed in, we like threw some teeth on these guys, right? Big fangs, like that. The crocodile would want to eat the bigger thing. So when you're doing it to place in numbers, you want the crocodile to open its mouth towards the bigger number. So for instance, if you look at A, you have 3 and 14. The crocodile would want to eat the 14, so you would use that symbol. That's how you guys probably learned it, okay? That's like every teacher uses that analogy, and it sticks with us, right? For whatever reason, that analogy sticks with us, even to the point where we're adults, right? I was doing this stuff yesterday, and Mr. Hart's like, oh, the alligator thing. Mr. Hart hasn't done math in forever, and he still remembers the analogy that the alligator eats the bigger number. Now, the problem is we have to be able to read it as well and understand what it's saying. So if you look at this, I know you're all good at putting the right symbol there, but are you good at what it's saying? So if you were to read that, it's saying 3 is less than 14. That's how I would read that statement. And you will need to be able to do that. Where you're headed is using like numbers with letters. So you're going to start saying in grade 10, like something is bigger than another something, and it won't be numbers. So it won't be easy to know which way the alligator should face, because you're going to be talking about hypothetical numbers, not actual numbers that exist. That's why being able to read it will be so important. Yeah, E is greater than F, right? You're going to have to be able to see things like that. That's why I want you to truly understand what each symbol's saying. So if I looked at 10, B, 10 is a greater number than negative 25. The symbol for greater than is this, right? That would read as 10 is greater than negative 25. Yes, sir.
I always just thought of it, like I was taught that it was like a Pac-Man trying to beat the greater.
Yeah. Oh, Pac-Man would work good. So, and I've seen the drawing, so they actually turn it into a little Pac-Man, right? Like this. Like there's a little Pac-Man eating the bigger number. Yeah, that works too. And like as long as you're putting the right symbol in, I'm happy. But I want you to try to get comfortable with reading it. Like, what is it saying to me? Because it's a skill that's going to be important later on in math. This year, you get away with the tricks. Next year, it's not going to be so easy. You're going to have to know which symbol means which thing. Yeah, D. Yes, sir. So if you look at C, negative 7 and negative 8. Negative 7 is actually greater than negative 8. Again, if you think of it in terms of money, if you had negative $7 or negative $8, like who would have more money? Technically, negative 7 would have more money. It's the bigger number. Seems weird. Yeah, you owe $7 or you owe $8, right? The person who owes $8 has less. They have to give away more. Again, this is negative 7 is greater than. Negative 8. And the last one we're going to do, I'm not going to write out the sentence. Negative 37 is less than negative 31. I know you're good with the symbols. That's why I'm stressing the words. And then in the future, you're also going to have like multiple things, right? So you'll have like X, Y, and Z, and you have to compare and order out those letters. So it gets tricky. If you know the words, it's a heck of a lot easier. All right. Number 4. We're just going to talk about integers that are, and then follow the rules. So for instance, for A, it says, write the integers that are 5 less than 0. Okay, so if you were at 0, and you want to be 5 less than 0, that means on a number line, at 0, 5 less is 5 to the left. 1, 2, 3, 4, 5. That means negative 5 is 5 less than 0. You could also do it mathematically as 0 minus 5. The number line is probably what you've seen the most of. If you look at B, it's talking about 2 less than negative 4. So if you started at negative 4, and you want to go less, that means you're going to the left. So 2 less would be negative 6. Again, mathematically, we could say that's negative 4 minus 2. Right? 2 less than something. If you look at C, we have between -2 and 2. If we're looking at our number line, -2 is here, +2 is here. Numbers in between would be -1, 0, and 1. D, 3 units to the left of -4. So if I'm at -4, 3 units to the left, 1, 2, 3, that'd be -7. 3 units to the left of -4. 2 units to the right of -3. So if we look at our question, -3 is right here. 2 units to the right would be -1. And yeah, F is the trickiest one because it's using symbol like greater than less than, which is a little bit tricky. And that is the kind of stuff you're going to have to be able to do eventually, is read statements like that. And so make you play use as your spot. So if you look at F, numbers greater than -10. If we're looking at a number line, -10 is right here. Numbers greater than -10 would be like -9, -8, -7, -6, all the way up. So we want to be greater than -10 and less than -6. Less would be to the left of -6. So the numbers that are greater than -10 but less than -6 would be these three: -9, -8, -7. Is that what you were going to say, Jacob? Do you have a question?
No, I was just gonna say, like, if you think about it on the numbers line, like, it's just right or left.
Yeah, you're always going right or left depending on the type of question. Greater than, right, less than, left. Yeah. Okay. Yeah. Awesome. Adding and subtracting. We're going to add and subtract some things. You can use a calculator for this unit. We're not going to right now. Okay, we'll focus more on the non-calculator stuff after Christmas. However, you could definitely do this stuff without a calculator right now. So the best way to do it is probably to use a number line because it's what you're comfortable with. So if you look at the first question, 3 is right here, plus -5. -5 is 5 to the left. That's how you would add something. You'd add -5 to the left. So if I started at 3, I would go 1, 2, 3, 4, 5. I would now be at -2. Adding a negative goes to the left. If you look at B, B starts at -4. And then you're adding a positive. So if you're adding a positive, that means you're going 6 to the right. There you go. 1, 2, 3, 4, 5, 6. It would get you to +2. If you look at C, C starts at -3. And then I'm adding -2. So that's 2 to the left. 1, 2 to -5. The next one, I'm starting at +2. I'm adding -7. That means I want to go 7 left because it's negative. So 1, 2, 3, 4, 5, 6, 7. It's also -5. Awesome. You can do E and F on your own. E. So E starts at -5 plus +2. That means 2 to the right. That would be -3. If you looked at F, it goes off our number line. So you started at -7. and you added negative 9, so you added 9 to the left because it was negative, that should get you negative 16. With a question like that, if I was to do it in my head, and this is how I do it, and I'll always show you like how I think through questions. Whether you want to think through questions the same way as me, that's your choice. I'm bad at adding negatives. Okay, so I have a negative plus another negative, not good at it. So instead, what I do is I do 7 plus 9. I turn them both into positives. I make them their opposite symbols. I know 7 plus 9 is 16, and then I just make it its opposite symbol again. So I just reverse it to make it back to negative 16. So sometimes that might help. You can only do that, though, if you're making everything a different symbol, right? So if I made both of them positives, it works. I couldn't make one positive and then add them together. That doesn't work. But honestly, that's how I do a question like that. Take my two negatives, turn them into two positives, then do my opposite symbol of my answer. Awesome. Subtracting integers. So there's different ways to do this. I'll talk about adding the opposite. I'm not a big fan of it, but people are good at adding. That's why we try to do it. So we try to get more addition rather than subtraction. I'm also just going to show you how I do it because I think it's easier. However, this is a method that people like to use as well. Adding the opposite. So we'll do questions A, B, and C as adding the opposite. And then I'll show you how I would tackle questions as well. So if you had A, instead of doing subtraction, we could add the opposite. So that means you change the subtraction to be an addition, and you make the second question or the second thing the opposite. So the opposite of negative 5 is positive 5. So instead of doing plus 3 minus negative 5, we do plus 3 plus 5 equals 8. Now, how I do it, and probably something you've heard before, is that two negatives make a positive. You heard that before?
Yeah.
So if you're subtracting a negative, we have two negatives back to back. We make that into a positive. So for instance, if you look at C, like I'm not a big fan of adding the opposite. I think it's kind of weird. If I looked at C, I would then say I have two negatives side by side. Two negatives make a positive. And I do negative 3 plus 2. That's how I do it. Have people seen that before? Two negatives make a positive? No? Yeah. A little bit? Just depends on the teacher you had, right? And the phrasing they use, right? Just like the alligator versus the Pac-Man, right? It's the same concepts, just different methods. So you'll see me do this the most. Two negatives make a positive. So if I'm subtracting a negative, I'm actually adding that number. So this would be negative 1. Hit it.
Are you just like you just flip the minus up and makes it plus?
Yeah, like they combine and one tilts. Yeah. Yep. Yep. All right, let's look at B. So B, we have negative 4 minus positive 6. Again, the idea of adding the opposite is that instead of writing it as negative 4 minus positive 6, you would turn it to negative 4 plus negative 6. Just because people are better with addition statements, I don't know. That's not how I would do it. I would just look at it as negative 4, and then minus 6 means go 6 to the left, which would be negative 10.
How is that negative?
It's negative 10.
So,
Negative 5.
so that's because you did negative 3 minus 2, but it's minus negative 2, and two negatives make a positive, so it turns into negative 3 plus 2. If you look at D, two negatives make a positive. All right, D. We have 4 minus 2. I think you should just be able to do it straight up by going 4 and then 2 to the left because you're subtracting. So that would be positive 2. Start at 4, go 2 to the left. If you look at E, we have 2 negatives side by side. 2 negatives make a positive. This is 2 plus 7. The answer is 9. If you look at F, you have negative 5 minus positive 2. I like to just look at that as minusing means 2 to the left. Right? So I have negative 5 and then go negative, so left, 2. If I have negative 5 and I go 2 to the left, I get negative 7. If I look at G, I would see these 2 negatives, and I would say 2 negatives make a positive. So this is negative 8 plus 1. That's negative 7. Right? Plus is going to the right. If you look at H, I have 3 minus 5. I look at minus as saying to the left, so I started at 3, go left, 5. That gives me negative 2. Yep. So if I'm talking number lines, I started at 3. 3. Come on. Started at 3. Minus means go left. And I go left 5. So 1, 2, 3, 4, 5.
Start at 5 and subtract 3. Like your normal add. No, that's not.
Because you're reversing it. So when you're like subtracting, it has to like subtraction of the order matters. So you have to have this number be first. It always has to be your starting point. You start at the first number. Always.
Why didn't you take the negative positive?
Yep. No. So Amy had a good question. She said for F, why wouldn't you do 2 negatives make a positive? Because there are 2 negatives there. So you're right. She saw these. She's saying 2 negatives make a positive. The negatives have to be side by side. So there's a number in between those negatives. That's why we can't do it. If you look at all the other ones, notice that the negatives are exactly side by side. There's nothing in between them. That's the difference. Okay, so the negatives have to be beside each other to do your 2 negatives make a positive. So if you look at G, for instance, the negatives have nothing in between them. There's no number in between them. So 2 negatives make a positive. That becomes negative 8 plus 1.
So zip zap, but then what? Okay, never mind.
You should say zip zap. Okay, example 7. So we use addition and subtraction of integers all the time, especially in just like everyday life when we're adding and subtracting things. We're going to look at some word problems. The first one's a little weird with the stairs, but hey, we'll do it anyway. So we have Jimmy starts at the bottom of the stairs at school. He climbs 6 stairs. Then he descends 3 stairs because he forgot his pencil. Then he remembers he can borrow one from the teacher, so he climbs 11 more stairs to the top of the staircase. How many stairs in total are in the staircase? So not how many stairs does he walk, but how many stairs are in the staircase. Okay, so if you were to think of this, it's probably best to do it as a number line where each number represents a stair. So he started at 0 stairs. He climbs 6 stairs. So he goes right 6. 1, 2, 3, 4, 5, 6. He then descends 3. So he walks down. Descends means down. So he goes back 3. So 1, 2, 3. He's at 3. Then he realizes he can go back to class, so he climbs 11 more. So then he goes 11 more. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Your job is to figure out what number that is. It's 14, which I agree. So if this is 6, that would be 7, 8, 9, 10, 11, 12, 13, 14. There's 14 stairs total. So you're adding and subtracting integers, and a number line probably works best, in my opinion. It kind of shows what's going on. Awesome. Mathematically, how we would represent that is we would say you had 6 stairs minus 3 stairs plus 11 stairs, and that equals 14. B, Mr. Brown has $150 in the bank. That means he's on a number line. He's starting at $150. He wrote checks for $80, $40, and $20. He then deposits a check for $110. What is his final bank balance? So if he's writing checks, that's like losing money, which is like going to the left on a number line, or subtracting. Depending on how you want to look at questions. When he deposits money, that's like adding money to your bank account, which is like going to the right on a number line. Depending on how you want to tackle a question like that. Me personally, I would say he has $150. He then writes checks, so loses $80, loses another $40, loses another $20, and then deposits, so adds $110. If you want to do this in your head, do it one at a time to figure out what you're at. You could definitely just throw in your calculator and that would work fine. The way I would do it in my head, if I have 150 and I lose $80, that means I'm down to $70 left. If I lose another 40, that means I'm down to $30 left. If I lose $20, that means I'm down to $10 left. And then I add 110, it means I have $120 total. Yeah. Awesome. If you look at C, the temperature outside at midnight is 0 degrees. The temperature rises 9 degrees by 6 a.m., then falls 12 degrees by 3 p.m. Finally, it rises 5 degrees by 7 p.m. What is the final temperature at 7 p.m.? It started at 0. It rises, that means plus 9. It falls, that means subtracts 12. And then it rises 5 more, that means add 5 more. If you did that, you should get 3 degrees Celsius is the temperature at 7 o'clock. Again, you can put that in your calculator. 0 plus 9 minus 12 plus 5. I'm with you. I'm like, why are people looking at me funny? And that's why.
Everybody looks at me funny.
Yeah, me too, man. It's 2. It's 2 degrees, not 3 degrees.
Confusing. I had the right answer, and then you said.
Well, yeah, that's why I was like, why are people looking at me funny? And usually when a lot of people look at me funny, it means I did something wrong. Awesome. Adding and subtracting, you guys have been doing that forever. It should be nothing new. So if you have a system that works for you, use that system. I'm giving you suggestions on how to do things and terminology I'll use. Multiplying integers. I think the biggest thing about multiplying is people forget a couple basic rules. The first thing is what multiplying is doing. So you would have learned a long time ago skip counting, right? That's what multiplying is. It's just skip counting, or groups of. So when you see a question like 3 times 6, like that's the first question they give us there. That means you have 3 groups of 6. So that means you can either count by 3s 6 times or count by 6s 3 times, and that would give you your answer. It's just skip counting, right? And you can reorder it however you want. So for me, I always count by whatever the biggest number is because that's easier. So if I was to do 3 times 6 in my head, I would do groups of 6 3 times. So skip count 6 3 times. 6. Another 6 is 12. Another 6 is 18. 6 times 3 is 18. Anybody here can multiply in their head. It's skip counting. And I know you guys know how to skip count. Right? So you can do multiplication in your head. It just means groups of. It's been so long since you learned the basics of multiplying, you probably forgot what was really going on. That's all it is. It's skip count. So when I look at 5 times 4, that's count by 5s 4 times. 5, 10, 15, 20. 5 times 4 is 20. It's just groups of. Skip counting. Life's pretty easy. The other rules that you learn is that if you have 2 positives multiplying, it'll always equal a positive. So the first example is showing you 2 positives always make a positive. The second rule you would have learned in math is that 2 negatives make a positive. So again, this idea of having 2 negatives makes a positive, it works for multiplication as well. -3 times -6 is a positive 18. That's probably the hardest one to wrap your head around with word problems. But it's just the mathematical rule. You talk about people like taking out negative money and then giving it away. Like it's a weird concept of how negative multiplication by another negative would work in the real world. It's just a weird thing to comprehend. The third rule is the one that you guys are usually pretty good at. It's at a negative and a positive. So if one's negative and one's positive, it'll always make a negative. Right? So a negative times a positive will always be a negative. Yeah, Joe.
8 times -7. What if you added times -7? That's still.
We're going to get to that. Yeah, we're going to get to that. Okay. Awesome. What if there's more than 2 things? If there's more than 2 things, they've got a whole bunch of things here, right? They've got all these statements multiplied together. The rule is if you have an even number of negatives, it will turn positive. So if you look, I like to pair them up. These 2 negatives would pair up to be a positive. These 2 negatives would pair up to be a positive. And then you'd have no negatives remaining. That's why even number of negatives will turn into a positive. If you have an odd number of them, like the question below, you'd have a negative times negative creates a positive, but then you have nothing to turn that negative positive. So an odd number of negative numbers will leave it as a negative answer. Beautiful. Looking at these, we're going to calculate them. When we're doing multiplication, especially in our head, I like to do the symbol first. So I have 3 times -5. Is my answer going to be positive or negative?
Negative.
Why? You're right. But why?
Because there's a positive and a negative.
Yeah, a positive and a negative multiplied to be a negative. So my answer is going to be negative. Then I focus on the numbers. So if I have 3 times 5, that means count by 5s 3 times. 5, 10, 15. -15 is my answer. Put the symbol first, then figure out the numbers.
Oh, wait, that's.
Yeah, 2 brackets beside each other means multiply.
Okay.
That's a good thing to note too. So if you look at B, that's -4 times 6, because there's nothing in between the brackets. Is my answer going to be negative or positive?
Positive. Right? Positive.
Negative. This time, it's because a negative times a positive always makes a negative. Right? So you have to have an even number of negatives to turn positive. Oh, sorry, yeah, you're looking at C. You're looking at C. Yep. So look at the symbols first, then do the numbers. 4 times 6. That means count by 6 4 times. 6, 12, 18, 24. If you look at C, is C going to be positive or negative, Brax? Yeah. Two negatives will make a positive, right? That's what you were looking at last time. Yeah, my bad. So I know I'm going to have a positive answer. Then I do the numbers. 3 times 6. 3 times 6 is 18 because 6, 12, 18. If you look at D, D will be a positive answer. Count by 7s 4 times. 7, 14, 21, 28. If you look at E, E will be negative. 2 times 7 is count by 7 2 times. 7, 14. Yes, sir.
So let's say that you're like timing a bunch of numbers together. If it's like at the end they're both like negative or negative positive, it's the same rule as these.
Yeah, so if there's an even number of negatives, it will turn positive. If there's an odd number of negatives, it'll turn negative. Yeah. If you look at F, we have a negative and a positive, so it's going to be negative. Count by 5s 2 times, that's negative 10. Yeah.
Do you have to, if it's a positive number as the answer, do you have to put positive?
No. So like for instance, this answer, you could just put 18, you could just put 28. You don't have to put the positive symbol. I'm just doing it to make sure people are aware that it's positive.
If you say like on the test, if it's like you have like one of those questions you say like the positive symbol, is that okay?
Yeah, that's fine. I'm just putting it there so you see that it's turning positive, just so it's very clear. Awesome. Number 9. We're not actually going to solve number 9. We're just going to predict whether it's positive or negative, Merrick. So to predict if it's positive or negative, you have to count the number of negatives being multiplied. So if you look at A, there's 1, 2, 3, 4 negatives. That's an even number. That means your answer will be positive. I like to pair them up, right? Because 2 negatives make a positive, 2 negatives make a positive. Now everything's positive. If I look at B, I have 1, 2, 3 negatives. Odd number means it'll be negative. Again, I could pair up the first 2 to become positive, but nothing could pair up with the last one to make it positive. Fantastic. Number 10. Using the integers, and they give you the first 1, 2, 3, 4, 5, 6. They give you 6 integers. I'm not sure why they put a dot, dot, dot. Which 2 integers produce the greatest product? Product means multiply. All right. If I'm trying to multiply to be the greatest possible number, that means I definitely want a positive answer because positives are bigger than negatives. So now I'm going to look at my things and be like, how can I get these guys to multiply to be a positive number? I could choose 2 negative numbers, or I could choose 2 positive numbers. All right, and ideally, I'm picking the biggest numbers of each. So let's try the negative situation. If I wanted to do the 2 negatives, that means I could choose -3 and -2 because those are the biggest numbers that are both negative. So -3 times -2 would become positive 6. And then I would try the same thing, but with the positive numbers. My biggest positive numbers are 4 and 1. So if I did 4 times 1, it equals positive 4. Those are the 2 biggest possible combinations I could create positive numbers with. Which one's bigger?
Green.
Yeah, the green one. -3, -2. Those are the 2 integers that create the greatest possible product. Yes, sir. Okay, so walk us through the next one. Don't just give me the answer. So if you're looking at B, 2 of the lowest, that means the smallest, would we want a positive or a negative answer?
You'd want a. You want
Just wait. I'm asking Merrick. You're on the right track. Merrick's right. He just let him answer the question. So, do you want a positive or a negative number?
positive.
Because if you go 0 times 1, anything times 0 is 0.
Correct. But is there a smaller number than 0?
Oh, negative.
Negative numbers would be the smallest. So my goal is to get a negative answer because that would be the smallest possible answer. To do that, you need to have what two type of numbers, Joey?
A negative and a positive?
You need one negative, one positive. If you look, the biggest positive is 4. The biggest negative is -3. So that's one possible answer. Because that would make -12. And negative numbers are smaller, right? The other possibility would be if you tried, nothing else really makes sense because 4 is the biggest positive and -3 is the biggest negative. So that's just automatically going to be your answer. -4 or -3 and +4. Remember, lower numbers, you want to go into the negatives. Bigger numbers into the positives. We're going to look at number 11. And then we're going to stop at dividing. Actually, no, we're going to keep pushing. So 11 says a hot air balloon rose from the ground at 5 meters per second for 10 seconds. It then descended at 2 meters per second for 6 seconds. How high off the ground is the balloon? So this would be a multiplication question. It's going up at 5 meters per second for 10 seconds. That means it's at 5, then 10, then 15, right? That's 5 times 10. I like to put brackets around my numbers when I'm multiplying. So like that. It then descends. That means subtract. And we're going to have 2 meters per second for 4 seconds. That would be 2, sorry, thank you, times 6. We've looked at questions like this before. This is bed mass, right? That minus sign in the middle, the red guy, is not -2. It's minus 2 times 6. So you must do bed mass on this by multiplying these two things first. 5 times 10 is 50. And then subtracting the green one, which is 12. 50 minus 12 is 38. So the balloon would be at 38 meters in the sky. Yep. Awesome. Dividing integers is the opposite of multiplication, meaning that instead of doing groups of, you would want to break it into groups. So if you're reading something like this, 15 divided by 5, that's saying how many groups of 5 could you get out of 15? And you could take 15 and you could break it up into groups of 5. So 5, 10, 15, 3 times. That one, it does matter the order in which you're skip counting. You got to skip count by the smaller number until you get to the bigger number, or the second number until you get to the first number. Our rules, though, for multiplication and division are the exact same. So if you have 2 positives or 2 negatives, it'll always turn into a positive. If you have different signs, it'll always be negative. So our rules are still the same. If you look at A, 24 divided by -6 will be a negative answer because it's opposite symbols. You then count by 6 until you get to 24. 6, 12, 18, 24. It's 4 times. That's how division works. If you look at B, B is going to be a positive answer because they're both negatives. 2 negatives divided will always make a positive. Count by the second number. So I'm counting by 9s until I get to 18. 9, 18. It takes 2 times. For C, my answer is going to be negative because I have one positive and one negative number. I'm counting by 5s until I get to 30. So 5, 10, 15, 20, 25, 30. It's 6 times. D is going to be a negative answer because I have one positive and one negative. I'm counting by 7s, the second number, until I get to the first number. So 7, 14, 21, 28, 35. 5 times until I get to 35. E, I have a negative and a negative. That's going to be a positive answer. I'm counting by 4s until I get to 36. 4, 8, 12, 16, 20, 24, 28, 32, 36, 9 times. F is going to be negative because I have one negative, one positive. Count by 6 until I get to 48. 6, 12, 18, 24, 30, 36, 42, 48. 8 times. You guys can all do multiplication and division in your head. It's just skip counting. If you know how to skip count, like which numbers you're counting by and how many times, you could do it. Anyone can. It's just adding, subtracting. You might not do it as fast as me, right? Like counting by 6s and 7s are kind of crappy numbers to count by. So it might take you a while, but you definitely can do it in your head. I know you can. You could do it backwards as well. So if you have 25 divided by something equals 5, that's a little trickier. I like to think of it as 5 times what would equal 25? Because I find that a little easier. So you can actually reverse these statements. Honestly, you don't have to do this a lot, so I'm just going to throw in the answer for you. 25 divided by 5, give me 5. So if I counted by 5s, it would give me 5. Something divided by negative 9 gives me positive 10. I know it's going to be a negative number because 2 negatives create a positive. And this would be negative 9 times 10, so that would be negative 90. This one would be negative 7 times something equals negative 63. That's positive 9. And D, it would be negative 4 times negative 11 equals something. That's positive 44. So you can reorder all those to be multiplication. I find it's easier to do it like that than the other way around. But hey, to each their own. To each their own means you can do it your own. Some people might do it their own way or have their own thoughts.
I heard each Simone.
Right?
Holy crap, there's 3 more examples.
Yeah, I think we are. No, we're not done. We're going to do question 14. So the same rules still apply. We shouldn't be packing up yet. So the same rules still apply. An even number of negatives will turn positive. So if you look at A, we have 1, 2, 3 negatives. That's an odd number, so the answer would be negative. Remember, you could pair them up. Those two would make a positive, but the last one wouldn't pair up, so it's still negative. If you look at B, we have 1, 2, 3, 4. That's an even number. Plus, if I look at it as pairing them up, I could pair everything up to turn positive, making it a positive answer overall. Same rule as multiplication, right? It's the exact same. If we look at these, use 2 of the 5 integers and write a division factor with each quotient. A quotient means like after you've divided. Right? Product was multiply, quotient is divide. So if we want a quotient of negative 2, that means we want something divided by something equals negative 2. If you look at your answer, we could do 4 divided by negative 2 equals negative 2.
Can you do negative divided by 4? Is that something different?
Nope, that'd be the same. That would be different because that would be counting by fours, right? So you'd be saying how many groups of 4 come out of 2, and it would only be a half. You can only do half of a group of 4 out of 2, so that wouldn't work. The greatest quotient. If we want a greatest quotient, we want a positive answer. So that means we want to do either 2 negatives and 2 positives. You could do either 12 divided by 3, or you could do negative 2 divided by negative 1. 12 divided by 3 would work better, because 12 divided by 3 is 4. The least quotient, you would want 1 positive, 1 negative, and you would want to divide by a smaller number. So I could have 12 divided by negative 1, and that makes negative 12, which would definitely be the smallest number possible. And a quotient between 5 and negative 10, negative 5, negative 10. Oh. So that means I'm trying to get an answer of negative 6, negative 7, negative 8, or negative 9, which I don't. Oh, we could do 12 divided by negative 2. That was hard for a second. Again, you can just guess and check some things until you get the lowest possible one, or you can try to work with how you're dividing numbers out.